In this video, we will examine what is trigonometry. First, a definition from our text. Trigonometry is the study of the relationships between the sides and angles of right triangles. And that can be extended out beyond right triangles, but for this course, that's all we'll be looking at. In the diagram there, you can see just a given right triangle, and I want to comment first on some of the labeling that could be used in textbooks. Notice the angles are marked capital A, B, C, and then the sides opposite those are using lowercase. So the side opposite capital A is lowercase a. The side opposite capital B is lowercase b, and C is also the same. So what we're going to do is look at the relationships that exist. And something that I want to point out in this video is proportionality. First, a few vocabulary words. We're going to refer to the legs of the triangle in a specific way. First of all, the hypotenuse will always be the hypotenuse. All right. That's HYP, hypotenuse. Okay. But when we're talking about a particular angle, we'll label the legs in a certain way. So for example, if I was to talk about angle B, if I was to focus on that, I would say that if I look at angle B, I have the legs are these two following relationships. A is next to it. We would call it, lowercase a is adjacent to that. We would say next to or adjacent. So I would say A is adjacent. Well, if I can spell it, adjacent to angle B, all right? And then look at the other leg, the other side that's not the hypotenuse, across from it. We're going to call that not across from, but opposite. So we'll say B is opposite angle B. I apologize for the messy handwriting. You could say the same thing in relationship to angle A. If you look at angle A instead of angle B, angle A's opposite side is lowercase a and adjacent side is lowercase b. We don't talk about angle C at all because it's just the right angle and it's always opposite the hypotenuse. Let's look at some specific examples of what I mean by proportionality with the GeoGebra drawing. So before this video started, I created this right triangle that you see here. This is a right triangle. I constructed it on the grid. The legs are 12 and 16. The hypotenuse is 20. So one way you may remember to check that is to make sure that, of course, 12 squared plus 16 squared is in fact equal to 20 squared, which it is. And you can verify that after this video. But what I want to talk a little bit about is the smaller right triangles that can be created inside it. And the way you do that is you can cut this up by putting a point anywhere on the hypotenuse. So let me give you an example. If I were to put a point right here in the middle, it appears to be the middle of the hypotenuse, and I were to draw either a vertical or horizontal line, notice what happens. First, a vertical. If I draw a vertical line here, I create this little miniature right triangle right there. Now, it has different dimensions. Of course, it's smaller. If you were to look at its dimensions, what would happen? Or if you were to create like I said, a horizontal line, you would create a little right triangle up there. It would also be like a shrunk down version of the big overall triangle. So what I want to do is examine, what happens when we do that and how do the side lengths basically work according to that. I'm trying to erase some of this out here so we can take a look at it. So I'm going to use GeoGebra to make these drawings. And so let's see. All right. So if I were to put a point exactly in the middle there, all right, exactly in the middle, and then I'm going to create my polygon. I'm going to create a little miniature. Well, I need to put one more point, actually. I need to put a point down here in the middle. All right, now I create a little polygon there, triangle there, so it's a smaller version. To really highlight this, what I'm going to do is I'm going to change the color of it, which you can always do. All right, let's see. Let me close that out now. Now you can really see that triangle. And if I were to look at its dimensions, that would give me even a little more detail. Well, since it's exactly half of this original large triangle, then I can label these where this taller leg would be 8, because 8 is exactly half of 16. And this shorter leg would be 6, because 6 is half of 12. If I use the Pythagorean theorem, here's what I would find out. The 6 squared plus 8 squared would actually be 10 squared. So this hypotenuse would be 10. And so what you might notice here is that when I do half, notice all of the sides are half. 8 is half of 16, 6 is half of 12, 10 is half of 20. We're going to exploit this in a future video.